All right, we did it. We made it through all of our pre-calculus videos, all of our review videos from things that you need to know before going into calculus. So today, we're going to actually start doing calculus. And we're going to go over the two main operations of calculus, but we're going to do it in a way that's different from what we're going to be doing the rest of the semester. The goal here is to simply give you a feel for some essential features of calculus and how they fit together. Recognize that some of the things that we're going to do are simplifications of what we will be doing later. And that to some extent there are things that we'll be leaving out, some important caveats that we won't be mentioning, because the goal here is to simply get you a taste for for the type of thinking and understandings we will look at going forward. All right, so let's get started. So the first operation we're going to look at today is the integral. And the integral is used for lots of different things, but the one that we're going to look at today is looking at the area under a curve. So now the integral itself, we actually won't cover in detail until further on down the course. But we'll introduce it here because there's a very simplified way of looking at it. Let's say that we have the equation y equals 2. It's a very simple equation. And it looks like this. Okay, so let's mark off our x's as well. And let's say, so we have this curve. And as I said, the integral, one of the things that it can be used for is finding the area under the curve. So even though our curve isn't very curvy, it's a straight line, the idea still applies. So let's just think about this. If I were to draw a straight vertical line at x equals 1, I've now enclosed a part of our graph. So let's say, what is the area of the shaded region? Well, y equals 2 is a straight line across. X equals 1 is a straight line up and down. Okay, so what does this form? Well, this forms a rectangle with a width of 1 and a height of 2. Well, rectangles, area equals length times height, or length times width, however you want to cut that cookie. In that case, that is 1 times 2 is 2. So the area at x equals 1, so we can say the area at x equals 1 is 2. Okay, so we can continue this. If I say x equals 2, well, that gives us a perfect square. It's going to look like this. So length times height, and that's going to be 4. So the area at x equals 2 is 4. And then x equals 3, this whole region, it's going to give us a 2 by 3. And the area at x equals 3 is 6. Now, do you see a pattern starting to form? 2, 4, 6. Okay, so it looks like that the area is simply doubling our x value. Okay, and so we can understand why this occurs, because think about this. On all of our different shapes, what is the height of each one of them? They all have the exact same height. They are all 2 high. Every single one of them, because y equals 2 sets our height at 2. And so what is the base? The base is always going to be whatever our x value is. Okay? So no matter what the x value is, that's going to be the length of this bottom side. So if x is 4, then the length of this bottom side is 4, and the height is still 2. Okay? So you're always going to have the area will be equal to 2, because that's the height, times x, because that's this bottom base. Okay, so in every case, the area is equal to 2 times x. And so another way of saying that is that the integral of y equals 2 is 2x. Okay, because this defines the area under this curve at any given x value. Okay, so I'm going to write this equation up over here, y equals 2. Now this itself is a function, and we can graph this on a graph just like we graphed this one. So we said that the graph, the area, was 2x. Be our graph. Y equals 2x. Okay? So 2x represents the area of this original curve, but it can be treated as a curve in its own right. What's interesting here is that if I draw a straight line, straight down, previously drawing lines straight down was giving us rectangles, but now it's giving us triangles. Okay? So let's say at x equals 2, what's the height? Well, the height is given as 2 times our x value. So at x equals 2, the height will be 4. How do we find the area of a triangle? Well, the area of a triangle is 1/2 base times height. So this would give us 1/2. The base is our x value, which is 2, and the height is the y value, which is 4. So that's going to be equal to 4. So, at x equals 2, the area will be 4. Okay, so what about at x equals 3? Okay, this still forms a triangle. So we still use the formula 1/2 base times height. So at x equals 3, what's our y value? Well, y is equal to 2 times our x value. So therefore, our y will be 6. So this will now be 1/2 times 3 times 6, which is equal to 9. So the area at x equals 3 is 9. Okay, so is there a nice way to make a formula for this one? Well, actually there is. So if we look at this, look at these triangles, no matter where we draw these x values, we're going to get a triangle. And the base of every triangle is going to be our x value. So our area will be equal to 1/2 our x value, which will be our base. Well, what's the height? Well, the height is our y value. So it'll be 1/2 x times y. Okay, well that's helpful, but it's not super helpful because we now have 2 variables here. So is there a way to get rid of one? Well, actually there is, because we have a formula up here which says that we can replace y at any point with 2x. So this becomes area equals 1/2 x times y, but y is 2x. Now, is there a way to simplify this? Well, yes, there is. We can rearrange this. We can give it 1/2 times 2. What is that? 1/2 times 2? That's 1, so that goes away. These cancel each other, and then I'm left with x times x. Well, what is x times x? It's x squared. So the area is equal to x squared. And we can see that that's what's happened so far. So when x was 2, the area was 4. When x was 3, the area was 9. And so when we get x equals 4, the area will be 16. So this is the integral of this. Okay, so the integral of 2x is x squared. So let's write what we have so far. So we started with y equals 2. And then we took the integral. And by that I mean we found an equation for the area under this curve. And that integral was y equals 2x. This gave us our graph where we were doing triangles. And when we found the area under that curve, which again is known as the integral, that became y equals x squared. So we have these series, and you can go on this, in theory, you could go on forever. That's kind of the limit of what you can do just with basic geometry. But we go from y equals 2, y equals 2x, y equals x squared. Okay. So that's one of the operations of calculus, is the integral, and that's finding the area under the curve. The other operation of calculus is the derivative. And the derivative tells you the slope. Okay, so let's go and look at our trusty equation. Y equals x squared. Now, what does it mean to find the slope? Okay, well, the slope at a given point is what happens if you imagine a line that runs through there and it touches the graph at exactly that point. Okay, and so you'll have a line. If you have a line that goes through here, it'll touch it at exactly this point. The slope of the line is the slope of the curve at that point. Okay, so you can see that this curve has a different slope here. So if we imagine a line that barely touches the graph, skims the graph at that single point, right? It's a much steeper slope. If we get to the bottom, the line that touches this is going to have a slope that's flat. Okay, so you can see that at any given point, we can draw a line that just barely skims it. You can use, if you have a graph of your own and you want to see what the slope is at a given point, you can just take your ruler or take a sheet of paper, right? And we can just adjust this so that it's, at one line, it hits the graph at one point, and we can draw a straight line, and then we can measure using our graph paper the slope of this line, and that's going to be the slope of the curve at that point. Okay? So now let's say that we want to know what it is, but we don't want to have to draw it. What's a way that we can calculate at least an estimate of what the slope is? Well, the way to think about it is to imagine that instead of hitting this at exactly one point, we're going to just pick 2 points that are close together. So if we take this curve, and let's say we want to know what the slope is at x equals 1. Now let's say that that's right here. Well, what you can do is you can imagine if we have 2 points on the graph, and we draw a line, because a point requires 2 lines, and we just, oh, that's not good. There we go. And we just draw a line from those 2 points. Well, that's an estimate of the slope. It's a bad estimate because those 2 points are so far away, but it's an estimate of the slope. How can we improve the estimate? Well, we can improve the estimate by moving the points closer together on the graph. So let's say instead of choosing this point way out here, that we instead chose a point closer in. Okay, so now we'll draw a line between these 2 points. So you can see we're not hitting the curve exactly, but we're a lot closer than we were. So we can move this point in, and the closer, because this curve is smooth and continuous, the closer these points get together, the more exactly it will be our slope. And this is known as the tangent line. It touches, it just barely touches the graph. And so if you find 2 points that are just barely close to each other, barely far apart, they will give you an estimate of what the actual slope is at that point. So let's do that here. So we're at x equals 1. And so remember, for a slope, we need 2 points. So what's our first point at x equals 1? Well, x equals 1, the y value is y equals x squared. Well, 1 squared is 1. So if x is 1, then y is 1. Right? So that's our first point. So for our second point, we'll move x over just a little bit, from 1 to 1.1. Okay, so if x is 1.1, what is our y value? Well, our y value is x squared. So if our x is 1.1, the square of that is 1.21. Okay, so now we have our 2 points. How do we determine slope? Well, slope is done using this formula. Because remember, the slope is merely the change in y divided by the change in x, or rise over run. So rise is the change in y, and run is the change in x. So we take our second y point, which is 1.21, subtract our first y point, which is just 1, and divide it by the difference in our x values, which is going to be 1.1 minus 1. This will give us 0.21 divided by 0.1, which will give us 2.1. Now remember, this is not the exact slope, this is an estimate of the slope. Okay? So the slope at x equals 1 is approximately 2.1. So let's do another value. Let's do x equals 0. So let's find the slope at x equals 0. So at x equals 0, y is equal to 0. So let's bump this over just slightly to x equals 0.1. Well, at x equals 0.1, y is 0.01. Okay, so we'll do this formula again. So it's y2 minus y1 over x2 minus x1. So the slope at x equals 0 is approximately 0.1. So let's do one more, and let's do x equals 2. Okay, so at x equals 2, y is going to be 2 squared. So at x equals 2, point will be 2, 4. And then we'll bump it up just a little bit. X equals 2.1. So x equals 2.1. What's 2.1 squared? That's going to be 4.41. Okay, so we'll substitute that in here. So 4.41 minus 4 over 2.1 minus 2. That's going to give us 0.41 divided by 0.1 can be equal to 4.1. So the slope at x equals 2 is about 4.1. So we have all these approximations. I will give you a secret that you will learn later on in the course, and that is the slope of these is actually, it's not 2.1, it's actually 2. It's not 0.1, it's actually 0. And it's not 4.1, it's actually 4. Okay? So if you notice, if I double 0, I get 0. If I double 1, I get 2. If I double 2, I get 4. The equation that represents the slope at any given point is actually the slope equals 2x. Okay? So at any given point, I can tell the slope of this curve by taking the x value of that point and multiplying by 2. So at x equals 12, the slope will be 2x. So the slope will be 24. And that's a very, very steep slope. It means we're going up 24 for every one that we go over. And so the slope is increasing, where the slope is equal to 2 times the value. You can also see that on the negative side. If you look at just x equals -1, well, the slope is -2. So that's about like that. So you notice on this side of the curve, the slopes go this way. They're negative because they've got negative x values. So the slope, if I start with y equals x squared, the slope is 2x. Okay? So 2x is also a function we can draw. So let's draw y equals 2x. That's just a straight line. Okay? So if it's just a straight line, what's the slope? Well, given a line, right? If you remember your equation for a line, y equals mx plus b, where m is the slope. Well, in this case, it's 2x plus 0, so 2 is the slope. So if I have the equation y equals 2x, then the slope at every single point is 2. Now I can draw that one as well. What does that look like? Well, if the slope is just 2 for every single x value, that's going to look like this. Now, I don't know if you've noticed this, but we started with y equals x squared, and we found the derivative, which means we found an equation for the slope, and the derivative was 2x. Then we found the slope again, which is the derivative, and the slope was 2. So you can see what's really the part of calculus that really revolutionized things was when it was realized that finding the area and finding the slope are actually inverse operations of each other. Okay? Or if I find the area under y equals 2, the area is 2x. But then if I want to find the slope of y equals 2x, I come back to here. And so every place we find the integral, the derivative is just doing the opposite thing to it. Okay, so those are our two main operations: the integral, which one of its main jobs is finding the area, and the derivative, which tells us the slope of a graph at any given point. And so those are the operations we'll be studying this year. And we'll be doing it, here we were doing it with geometric figures that we can understand using the geometry that we've used forever. And going forward, we'll find the areas and slopes of much more complicated figures. And then we'll find a lot of things that you can do with areas and slopes that might be surprising. So that is your introduction to calculus. That's an overview of kind of what we'll be doing in this course.